Hello students and good afternoon. So now I am doing class for class 12. The topic is binary operation. So in the last online class we did the theory portion on binary operation and we also did some problems on binary operation from the book Senior Secondary School Mathematics for class 12 by R.S. Agarwal. So today we will continue the same chapter, that is binary operation, and today we will do more problems on this chapter, that is binary operation, right? So same exercise 3A, page number RF, that is relation and function, page number 60 from the book Senior Secondary School Mathematics for class 12 by R.S. Agarwal. Okay, so now let's do this question. So yesterday, that is in the last online class, we did question number 1. So now we'll do question number 2. You have to show that this number 1, this star is a operation, binary operation. This star on Q means rational numbers defined by A star B is equal to AB divided by 2 is commutative as well as associative. You have to prove that this operation star on the set of rational numbers defined by A star B is equal to AB by 2 is commutative as well as associative. Okay, so you have to prove commutative as well as associative. So what is the meaning of commutative? Commutative means you have to take two elements that belong to the set of rational number Q and you have to prove for commutative A star B is equal to B star A. So now in this case you have to prove A star B is equal to B star A. Is that clear? Now let us prove it now. For commutative law you have to prove A star B is equal to B star A. Okay. So now here it is given that here given is A star B is equal to AB by 2. Right? So can you write B star A? What is B star A now? So instead of A you put B and instead of B you write A, right? So or B star A is equal to, that means instead of A we are putting B and instead of B we are putting A. So here also you put B for A and A for B divided by 2. So that means obviously these two are equal. AB divided by 2 is equal to BA divided by 2. Or you can give the example also. That is, suppose A is equal to 3, A is equal to 3 and B is equal to 4. So what is 3 star 4 is equal to 3 into 4 divided by 2, right? So A is equal to 3, B is equal to 4. You can give the example also in order to prove that A star B is equal to B star A, right? So 3, A is equal to 3 and B is equal to 4. So 3 star 4 according to this definition will be 3 into 4 divided by 2. That is, it is 12 divided by 2 which is equal to 6, right? So now let us write here 4 star 3 now. So which is equal to now 4 star 3, right? So instead of 3 here you should write 4 now, and instead of 4 you should write 3 divided by 2 which is equal to 12 by 2 which is equal to 6. That means they are equal. So 3 star 4 is equal to 4 star 3 in this case. Okay, that means in this case also AB by 2 is equal to BA by 2. So hence we can write A star B is equal to B star A, right? So therefore the operation star is commutative. That is, the operation star is commutative. Therefore the operation star is commutative. So we have proved that star is commutative in this case. Okay, so we can copy it. So now we will prove for associative. Okay, now we will prove for associative now. Now, what is associative law? So you know that associative law is, let us take the three elements A, B, C that belong to the set of rational numbers. And for associative, you have to prove this relation. That is A star B star C is equal to, you have to prove A star within bracket B star C. Okay? So in this case, A, B लाई चाहिँ हामीले within bracket भित्र लेख्यौं, C लाई चाहिँ बाहिरपट्टि लेख्यौं. अब राइट साइडमा चाहिँ B and C are kept within bracket अनि A लाई चाहिँ हामीले केमा लेख्यौं, बाहिरपट्टि लेख्यौं. ठीक छ? So let us prove this relation in order to prove the associative property. Okay? So now let us prove it now. So here given is, let us write down given. Here given is A star B is equal to AB by 2. Right? So let us find out within bracket A star B star C. So A star B star C, which is equal to, now in the question this A star B is defined as AB by 2. So instead of A star B, you have to write AB by 2 here. So this is AB by 2 star C. I think you have understood it. So now which is equal to, now again this is in the form A star B, isn't it? Instead of A, there is AB by 2 now. Instead of A, what is here? AB by 2, right? And instead of B, what is here? C. अब हामीले के गर्छौं भन्दाखेरि यो AB by 2 A को जग्गामा आयो. That is A is equal to AB by 2 and B को जग्गामा के आयो? C आयो. ठीक छ? The similarity is AB by 2. So what is A in this case? A भनेको यो सबै AB by 2 नै भइगयो. त यहाँ हामी के लेख्छौं? AB by 2 लेख्छौं. It is AB by 2. So instead of B, what is there? Instead of B, there is C. A भनेको यो AB by 2 आइगयो. त यो A को जग्गामा हामीले AB by 2 लेख्यौं. अनि यहाँ B को जग्गामा यहाँ के छ? C. So you should write here C divided by 2, which is equal to, now we can simplify it, which is equal to ABC divided by, though both these two are in the denominator, so it is 2 to the 4. So it is ABC by 4. That is within bracket A star B star C is equal to, what is this value? It is ABC by 4. Now you should find out A star within bracket B star C. So again A star within bracket B star C, right? So which is equal to, now this A is kept as it is star. Now what is B star C from this definition? Instead of A there is B, instead of B there is C. So what should you write for A? You should write B now. It is B, and instead of B what should you write? C. So it is BC by 2, right? So I think I've understood it. B star C. Now instead of A there is B, and instead of B there is C. On the right hand side also, instead of A there is B, and instead of B there is C divided by 2. Now again here A is A only. What is B here? It is BC by 2. Instead of B you have to take BC by 2. Okay, so what is here now is equal to A. This is your A. This is A is kept as it is. Instead of B, what is there? BC by 2. So what should you write for B here? It is BC by 2. It is BC by 2 whole divided by 2 is here. So which is equal to, now you can multiply them. So ABC, this is ABC divided by, both these two are in the denominator, that is 2 to the 4. So obviously these two are equal, isn't it? That is ABC by 4 is equal to ABC by 4. So hence we can write here, hence A star B star C is equal to A star within bracket B star C. So hence this operation star is commutative. So hence the operation star is not commutative, that is your associative now. This is known as associative property, not commutative. Commutative means A star B is equal to B star C. But in this case, we have proved that within bracket A star B star C is equal to A star within bracket B star C. That is your associative property. So hence star is associative. Hence star is associative. So it is proved. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we will do the next problem, that is number 2. Here also you have to prove that star on Q, Q means set of natural numbers, defined by A star B is equal to AB plus 1. Now A star B is defined as AB plus 1 is commutative, but it is not associative. Now first of all, let us prove it for commutative. Commutative means you know that A star B is equal to B star A, isn't it? So in order to prove for commutative, we have to prove A star B is equal to B star A, right? So let us prove it now. So given here is A star B is equal to AB plus 1. Okay. So if A star B is equal to AB plus 1, let us find out B star A. So now B star A is equal to, so instead of A we have written here B, and instead of B we have written here A. Okay. Similarly on the right hand side also, instead of A you have to write B, and instead of B you have to write A. This is BA plus 1. So you know that AB plus 1 is equal to BA plus 1, isn't it? AB plus 1 is equal to BA plus 1. It is equal always. So hence A star B is equal to B star A. So therefore this operation star is commutative. Hence operation star is commutative. So I think you have understood it. Okay. So now this is for commutative. A star B is equal to B star A is for commutative. Now for associative, you have to prove that, you know that for associative you have to take the three elements A comma B comma C, all belongs to the set Q, rational number, right? So you know associative law is within bracket A star B bracket closed star C is equal to A star within bracket B star C. So if you can prove this LHS is equal to RHS, then star will be associative, otherwise star will not be associative. That is, if this LHS not equal to RHS, then star will not be your associative. So in this case also you have to prove that this star is not associative. Is that clear now? So let us prove it now. For not associative, you have to prove this LHS not equal to RHS. Okay. So therefore, let us find out first within bracket A star B star C, which is equal to. Now first of all, let us put the value for A star B. This A star B is defined as what? It is AB plus 1, right? So this is AB plus 1 star C. Is that clear? Next, so how can you find out the value for AB plus 1 star C using A star B is equal to AB plus 1? Okay, so you can compare these two expressions now. So instead of A, there is AB plus 1. Instead of B, there is C. ठीक भयो त हामीले के याद गर्नुपर्छ भन्दाखेरि यो A को जग्गामा अब के लेखेको छ AB plus 1. अब A को जग्गामा हामी AB plus 1 लेख्छौं अनि B को जग्गामा के लेख्छौं C लेख्छौं. ठीक छ त राइट साइडमा AB plus 1 छ. अघि नै मैले भने यो A को जग्गामा के लेख्नु पर्छ AB plus 1. So let us write it within bracket AB plus 1, right? So instead of B, what should you write? C. You should write C. And plus 1 is constant, it remains same, plus 1. So I think you have understood it. So let us simplify it. So which is equal to, this AB plus 1 should be multiplied by C, you know that. So it is ABC plus C plus 1. So this is your within bracket A star B star C. So I think you have understood this A star B star C. A star B within bracket star C is how much is that? ABC plus C plus 1. Okay. So next you have to find out this right hand side, A star within bracket B star C. So now A star within bracket B star C, which is equal to, now here also this A star B is equal to AB plus 1. So let us write down the value for B star C first. Instead of A there is B, instead of B there is C, this will be BC plus 1, isn't it? So this now, this first term remains same, A star, and within bracket, what is B star C given in the question? Instead of A you have to write B, instead of B you have to write C. So this right hand side becomes BC plus 1. Is that clear? So this is your BC plus 1, which is equal to, now again how will you simplify it? Now instead of A there is A, instead of B there is BC plus 1. So it is defined as AB plus 1, right? So here A is A only, you write A, and what is B here? It is BC plus 1. It is BC plus 1, and then this plus 1 is constant, you have to write plus 1 as it is. Is that clear? So now let us multiply this BC plus 1 by A. So it will be ABC plus A1s are A, this is plus 1. So can you say that these two expressions are equal? No, they are not equal. This is ABC, this is ABC, but this is C and here it is A. So these are not equal. So therefore A star B star C not equal to A star within bracket B star C. That means star is not associative. Therefore star is not associative. Therefore star is not associative. So it is proved. So you have understood it, I think. Okay, you can copy it. Now we'll do the next question. Now we'll do the next problem, that is 2 number 3. You have to prove that this operation star on Z plus. So what is the meaning of Z plus? Z plus means set of positive integers. Z plus means set of positive integers. So defined by A star B is equal to A to the power B. So both these A and B are Z plus, that is positive integers. You have to prove that this star is neither commutative nor associative. यो commutative पनि हुँदैन, associative पनि हुँदैन भनेर हामीले प्रुभ गर्नुपर्छ. बुझ्यो तिमीले यो? So I think you have understood it. So let us do this problem now. So now in order to prove for commutative, you have to prove A star B is equal to B star A. But in this case, it should not be commutative. That means you have to prove A star B not equal to B star A. So let us give an example now. So let us take A is equal to 2 and B is equal to 3. A is equal to 2 and B is equal to 3, right? So therefore, you know that A star B is equal to A to the power B. It is defined as, it is given in the question, A star B is equal to A to the power B. So let us find it now. Or what is A here? It is 2 star. What is B here? It is 3 is equal to, it is defined as what? Instead of A you write 2, instead of B you write 3, which is equal to what is 2 cube? It is 8. Is that clear? Next. Now next again, now we have to find out B star A is equal to, what is B star A now? It is B to the power A. Instead of A you put B, instead of B you put A, which is equal to, instead of A if you write B and instead of B if you write A, it will be B to the power A, isn't it? So, or now what is B out here? It is 3. This is star 2 is equal to, what is B to the power here? A here, it is 3 square. So 3 square is what? It is 9. So are they equal? 8 and 9 are equal? No, they are not equal. So these 8 and 9 are not equal. So I think you have understood it. So this A star B not equal to B star A. That means this A star B not equal to B star A. So therefore A star B not equal to B star A. That means star is not commutative. Therefore star is not commutative. Therefore star is not commutative. So I think you have understood it. So now let us prove that this star is not associative. Is not associative means within bracket A star B star C is equal to A star within bracket B star C. That should not be equal. This LHS should not be equal to RHS. Okay. So now here also let us take an example. Let A is equal to 2, B is equal to 3 and C is equal to 3. All these belong to the set of positive integers. Okay. So now let us find out first. Therefore A is star B within bracket is star C. Right. So which is equal to, what is A here? It is 2 star, what is B? It is 3 star C. What is C in this case? C is 4. Right. So now by definition, what is 2 star 3? Here instead of A there is 2, here instead of B there is 3. So it is A to the power B. So in this case it becomes 2 cube star 4. It is 2 cube star 4. So I think you have understood it. Now in this case, this 2 cube is A. In this case, this 2 cube is what? A, right? This 2 cube is A, and what is B here? It is 4. So use the formula. Instead of A, there is 2 cube. It is 2 cube whole to the power. What is B here? It is 4. So which is equal to, this is 2 to the power 3 4s are 12. So keep it as it is. This is 2 to the power 12. I think you have understood it. Okay. Now let us find out A star within bracket B star C. So let us find out A star within bracket B star C. So which is equal to, what is A here? It is 2 star. What is B here? It is 3 star 4, which is equal to 2 star. Now in this case, instead of A there is 3 and instead of B there is 4. So it is A to the power B. So it becomes 3 to the power 4. So it becomes 3 to the power 4. Okay. Now in the next step, now here A is 2 and B is 3 to the power 4. So according to the definition, it is A to the power B. What is A in this case? It is 2. And to the power B, what is B here? To the power B is 3 to the power 4 is equal to, this will be 2 to the power 81. What is 3 to the power 4? 3 to the power 4 is 3 to the power 4 is 3 is multiplied 4 times. 3 3s are 9, 9 3s are 27, 3s are, this is 81. So are they equal? No. That means we can write here A star B star C not equal to A star within bracket B star C. That means they are not equal. So hence star is not associative. So therefore star is not associative. Therefore star is not associative. So I think you have understood it. So you can copy it. Now we'll do the next question. So now let us do this question number 4 of number 2. So that this operation star on Z. Z means set of integers. It may be set of positive integers, it may be set of negative integers including 0 also. Okay? Defined by A star B is equal to A minus B is neither commutative nor associative. तो यो कम्युटेटिभ पनि हुँदैन एसोसिएटिभ पनि हुँदैन भनेर हामीले प्रुभ गर्छौं. So for associative law, for commutative law, you know that A star B is equal to B star A for commutative law, and for associative law, within bracket A star B star C is equal to A star within bracket B star C. Okay? So now let us prove the first part, that it is not commutative. Let us give an example now. So let here also you take A is equal to 2 and B is equal to 3. Okay? So therefore A star B is equal to, it is defined as A minus B. Okay? So or what is A here? It is 2 star, what is B here? It is 3, which is equal to, it is defined as, instead of A there is 2 and instead of B there is 3. So it is 2 minus 3 is equal to minus 1. So this is your A star B is minus 1. Again now you have to find out B star A is equal to, now instead of A there is B and instead of B there is A. So it will be B minus A. Right? So or what is B in this case? It is 3 star, what is A? 2. A is 2 here, which is equal to 3 minus 2 is equal to 1. So these are not equal, isn't it? That is minus 1 not equal to 1. That means this A star B not equal to B star A. So therefore A star B not equal to B star A. That means star is not commutative. Therefore star is not commutative. Therefore star is not commutative. So I think you have understood it. So this is the first part. Now for the second part, you have to prove that star is also not associative. So in this case you have to prove within bracket A star B star C is equal to A star within bracket B star C, not equal to. Okay? So now here also let us take an example. Let A is equal to 2, B is equal to 3 and C is equal to 4. So let us take these 3 positive integers that belongs to the set Z. Okay? So now in this case let us find out first A star B bracket star C, right? So which is equal to, now let us put the value here. What is A in this case? It is 2 star, what is B here? 3 star, what is C here? It is 4. Now by definition A star B is equal to A minus B, so you can write here 2 minus 3 star 4. 2 minus 3 star 4, which is equal to, now this is your minus 1 star 4. So I think you have understood it. So now again this minus 1 star 4, instead of A there is minus 1, instead of B there is 4, so it is A minus B. So what is A minus B out here? It is minus 1 minus 4, which is equal to minus 5. Is that understood now? So now let us find out next, that is your A star within bracket B star C, which is equal to, now what is A in this case? Again put those values. 2 star within bracket, what is B star C? It is 3 star 4, which is equal to 2 star is kept as it is. So by definition, what is 3 star 4? Instead of A there is 3, instead of B there is 4. It is A minus B, so it is 3 minus 4, right? So which is equal to 2 star within bracket 3 minus 4 is minus 1. Now again it is, instead of A there is 2, instead of B there is minus 1. It is defined as A minus B, so it is 2 minus within bracket minus 1, which is equal to 2 plus 1 is equal to 3. So are they equal? Minus 5 not equal to 3. That means these two are not equal. So therefore within bracket A star B star C not equal to A star within bracket B star C. So what can you write for associative? This star operation is not associative. So therefore this star is not associative. So star is not associative. So hence star is neither commutative nor associative. So we have proved it. So you can copy it. So now we'll do the next question. Now we'll do the next question, that is 2 number 5. That is, you have to show that here also this operation star on R. R means real number. R minus within second bracket minus 1 is given here. That means all those set of real numbers except minus 1. यो real number set मा चाहिँ यो minus 1 चाहिँ exclude गरिन्छ. Minus 1 चाहिँ हुँदैन त्यहाँ. This minus 1 is excluded from this set of real numbers. Okay. So defined by A star B is equal to A upon B plus 1. So why is this minus 1 excluded from this set of real numbers? Because if you put B is equal to minus 1, this minus 1 plus 1 will be 0, isn't it? This minus 1 plus 1 will be 0. That is denominator 0. Undefined. That is meaningless. That is your undefined number. That's why it is given R minus minus 1. That means minus 1 is excluded from those set of real numbers. So I think you have understood it. So you have to prove that this star operation is neither associative nor commutative. You have to prove it. Okay. So here also let us give an example. So let us take A is equal to 2 and B is equal to 3. Okay. So let us find out A star B first. So therefore A star B is defined as A upon B plus 1. Okay. So now, or what is A here? Instead of A you can put A here. 2 star, what is B in this case? 3, which is equal to, what is the value for A? It is 2 divided by, what is B? This is 3 plus 1, which is equal to, this is 2 by 4, which is equal to half. Is that understood now? Next, now we have to find out B star A. For commutative, you have to prove A star B is equal to B star A, isn't it? So now B star A now becomes, so instead of A there is B, instead of B there is A. So right hand side becomes, instead of A you have to write B, and instead of B you have to write A plus 1. Here also A is not equal to minus 1. So minus 1 is excluded here because minus 1 plus 1 is 0. That is, if denominator is 0, this is undefined. Is that clear? That's why A not equal to minus 1. Right? So, or, now what is B in this case? It is 3. Star, what is A here? A is 2, which is equal to, now instead of B you have to put 3 divided, what is A? A is 2. 2 plus 1, which is equal to 3 by 3 is equal to 1. So are they equal? No. So that means therefore A star B not equal to B star A. That is, star is not commutative. Therefore the operation star is not commutative. Is not commutative. Okay, so this operation star is not commutative. So I think you have understood it. So now let us check for associative. So here also let us take A is equal to 2, B is equal to 3, and C is equal to 4. All this belongs to the real numbers, right? So A is equal to 2, B is equal to 3, and C is equal to 4. So now let us find out, in order to prove associative law, you should have within bracket A star B star C is equal to A star within bracket B star C. So let us find out first A star B star C. Let us find out its value first. So which is equal to within bracket, what is A star B now? 2 star 3 star, what is C here? This is 4, which is equal to, now how is it defined? 2 star 3, A is equal to 2 here, B is equal to 3 here. Okay, so here A is 2 divided by, what is B here? It is 3. 3 plus 1 star 4, which is equal to, this is 2 by 4 star 4. So which is equal to, this is your half, isn't it? So this is half star 4. This is your half star 4. Now instead of A there is half, instead of B there is 4. So we can use A by B plus 1. So what is A in this case? A is half divided by, what is B plus 1? It is 4 plus 1, right? So which is equal to, this is half divided by 4 plus 1 is 5 divided by 1. So if you simplify it, that is when this 5 by 1 goes up in the numerator, it becomes upside down, that is 1 by 5, which is equal to, this will be your 1 by 10. That is A star B bracket closed star C is equal to 1 upon 10. Okay. Now let us find out A star within bracket B star C. So now let us find out, therefore A star within bracket B star C, which is equal to, what is A here? 2 star within bracket, what is B star C? It is 3 star 4, which is equal to, this is 2 star, what is 3 star 4? Instead of A there is 3, instead of B there is 4. So it is defined as A upon B plus 1. Here A is 3. So 3 divided by, what is B plus 1? It is 4 plus 1. Here B means 4, that is plus 1. Okay. So let us simplify it. 2 star, this is 3 divided by 4 plus 1 is 5. Now again you have to use this definition. So in this case, A is equal to 2 and B is equal to 3 by 5. It is defined as A upon B plus 1. So what is A in this case? 2 divided by, A here is 2, and what is B plus 1? It is 3 by 5 plus 1. Let us simplify it. So which is equal to 2 divided by, you can add them, 5 ones are 5 plus 3 is 8. 8 divided by 5 is equal to 2 into, now when this 8 by 5 goes up in the numerator, it becomes upside down, that is 5 by 8. So here 2 ones are 2, 2 fours are 8, which is equal to 5 by 4. So are they equal? 1 by 10 and 5 by 4. They are not equal. That means A star B within bracket star C not equal to A star within bracket B star C. So therefore A star B star C not equal to A star within bracket B star C. So therefore star is not associative. Therefore star is not associative. Therefore, star is not associative. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 3. Define star operation star on Z by A star B is defined as A plus B minus AB. Okay, A star B is defined as A plus B minus AB. You have to prove that star is a binary operation of Z. That is, you have to prove that star is a binary operation on Z. That means, how will you prove it? If this A belongs to the set Z, Z means set of integers. It may be positive integers, it may be negative integers, including 0. Okay. If A belongs to the set Z and B belongs to the set Z, then obviously this expression A plus B minus AB also belongs to the set Z. So star is a binary operation. You know that, isn't it? So let us first show that star is a binary operation of Z. Okay. So now here, given here is, here the A star B is defined as A plus B minus AB. Okay, this is defined. This is defined, that is A star B is equal to A plus B minus AB. So now, you know that A belongs to the set Z, that is set of integers. A belongs to Z, B belongs to Z, which implies that this expression, that is A plus B minus AB, also belongs to the set of integers. Obviously this A plus B minus AB belongs to the set of integers. Okay, so therefore star is a binary operation. So star is a binary operation. So we have proved that star is a binary operation for the first part. Okay, now we have to prove that this is commutative as well as associative. यो commutative पनि हो, associative पनि हो भनेर प्रुभ गर्छौं अब हामी. ठीक छ? So now it is given A star B is equal to A plus B minus AB. Now in order to prove that commutative, A star B should be equal to B star A. Okay, now instead of A, or, so therefore B star A. And now instead of A we are writing B, and instead of B we are writing A, right? So for A you should write B plus, for B this is A minus BA. But these are same expression, isn't it? A plus B ra B plus A एउटै हो, AB ra BA पनि एउटै हो. That means they are equal. So therefore here we have proved that A star B is equal to B star A. So hence star is commutative. Hence star is commutative. Hence star is commutative. So I think I've understood it for commutative part. Now we have to prove for associative law. So in order to prove associative law, you have to prove that within bracket A star B star C is equal to A star within bracket B star C. Okay, so now let us find out first A star B star C, which is equal to. So actually what is A star B now? A star B is A plus B minus AB, right? So instead of A star B you can write down its definition, that is your A plus B minus AB. So it is A plus B minus AB star C. Is that clear now? So A star B भनेको हाम्रो कति हो? A plus B minus AB हामीले यहाँ लेख्यौं. Star C is kept as it is. त्यो हामी जस्तो छ त्यस्तै लेख्छौं. ठीक छ? Now how will you simplify this A plus B minus AB star C? Now instead of A, यो A को जग्गामा अब के आयो? A plus B minus AB. यो A को सट्टामा के आउँदैछ? A plus B minus AB. अनि यो B को सट्टामा के आउँदैछ? C. यो डल्लै तिम्रो के भयो? A, यो C चाहिँ के भयो? B भयो. So now which is equal to, now you should write A first. But what is A here? A plus B minus AB. This is A plus B minus AB is your A. Plus, what is B here? It is C. It is C, right? So then write down minus sign. So instead of A, what will you write now? Again, A bhaneko थियो A plus B minus AB. So within bracket, A plus B minus AB bhayego yo. Bracket close. This is your A. What is B here? It is C. So you should write here C. I think you have understood it. Okay. So let us simplify it. A plus B minus AB plus C. Now let us multiply them. Minus AC minus into plus minus BC. And this minus into minus plus. This is your ABC. So what is the value for within bracket A star B star C? It is A plus B minus AB plus C minus AC minus BC plus ABC. So यसलाई हामी अलिक मिलाएर लेखौं. So is equal to, this is your A plus B plus C, right? A plus B plus C. Then write down minus AB minus AC minus BC plus this is your ABC. That is, we have got the value for within bracket A star B star C. Now let us find out A star within bracket B star C. So again let us find out A star within bracket B star C. So now let us find out its value, right? So which is equal to this first term A is kept as it is, A star. Now what is B star C? Instead of A there is B, instead of B there is C. त हामी A को जग्गामा B लेख्छौं अनि B को जग्गामा के लेख्छौं? C लेख्छौं. त यो कति हुन्छ त? अब हामीले A को जग्गामा B लेख्नु पर्यो प्लस B को जग्गामा C लेख्नु पर्यो. Minus, what is AB here? Instead of A you have to write B, instead of B you have to write C. So this is BC. So is that clear to all of you? I think you have understood it. Now again this is in the form A star B form, isn't it? So instead of A there is A, instead of B there is B plus C minus BC, and it is defined as A plus B minus AB. Is that clear? तो यहाँ A को जग्गामा के छ? A नै छ. यहाँ B को जग्गामा के छ? B plus C minus BC. ठीक छ? So which is equal to A भनेको A नै छ यहाँ. A plus, what is B? This whole term is B. Let us write it. B plus C minus BC, right? Then minus. So what is A here? This is A only. And what is B here? What is the value for B? B is whole thing, that is B plus C minus BC. That is B plus C minus BC. Understood now? So let us simplify it. So let us simplify it here. So which is equal to first three terms, that is your A plus B plus C, then minus BC. Now we have to multiply by minus A there, minus AB, minus into plus, minus AC, minus into minus plus. This is minus AB, minus into plus, that is your minus, minus into plus is minus AC, and minus into minus plus, that is your ABC. So are these two expressions equal? Check it. Let us check it. A plus B plus C, A plus B plus C is there. Minus AB, minus AB, minus BC, minus BC, minus AC is there, and plus ABC is also there. That means these two expressions are equal. So therefore we have proved that within bracket A star B star C is equal to this A star within bracket B star C. These two are equal. That means the star operation is associative. So therefore star is associative. Therefore star is associative. So it is proved. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 4. Define star on Z. Here Z is a set of integers, positive integers, negative integers including 0. It is defined by A star B is equal to A minus B plus AB. A star B is given as A minus B plus AB. You have to show that first star is a binary operation in Z, but this star is neither commutative nor associative. यो कम्युटेटिभ पनि होइन, एसोसिएटिभ पनि होइन भनेर हामीले प्रुभ गर्नु पर्यो। त पहिला चाहिँ हामी के देखाउँछौँ, स्टार इज अ बाइनरी अपरेसन भनेर देखाउँछौँ। And then you have to prove that this star operation is neither commutative nor associative. Okay? So here given is, let's do the solution. Here given is A star B is equal to A minus B plus AB. Now, if A belongs to the set of integers and B belongs to the set of integers Z, so can you say that A minus B plus AB belongs to the set of integers? Yes, it might be negative, it might be positive, including 0 also. Okay, so therefore A belongs to Z and B belongs to Z, which implies that A minus B plus AB belongs to the set of integers. So that is, therefore star is a binary operation. So star is a binary operation. So star is a binary operation. So I think you have understood it. Okay. So now let us check for commutative. So therefore A star B is given as what? A minus B plus AB. Okay. So what is B star A? So instead of A, let us write B, and instead of B, let us write A. So it becomes B minus A plus B minus A. Instead of A, write B. Instead of B, write A. And for A, you write B, and this is A. So in this case, these two expressions are not equal. So why are they not equal? AB is equal to BA. Huncha tyo. AB is equal to BA. But A minus B is not equal to B minus A. If you have 3 minus 2 is equal to 1. But can you say that 2 minus 3 is also 1? No, this is minus 1. Is that clear? That means A minus B not equal to B minus A. That's why these two expressions are also not equal. So they are not commutative. That means, therefore, A star B not equal to B star A. So therefore star is not commutative. Therefore star is not commutative. Understood? So next let us check for associative. So now let us check for associative. Let us find out the value for within bracket A star B star C, within bracket A star B star C, which is equal to, now let us put the value for A star B. It is defined as what? It is A minus B plus AB star C. Now how will you simplify it now? So instead of A, now there is A minus B plus AB, right? So instead of A, what is there? A minus B plus AB. And instead of B, what is here? It is C. Okay. So let us use this definition. So instead of A, what is there? A minus B plus AB. Then minus sign is there. Minus sign. What is B here? It is C. Right? Then plus. Plus. What is A? A is whole expression, that is A minus B plus AB into what is B? Into C. So I think you have understood it. Okay. So let us simplify it first. So this is A minus B minus C. Minus is written first here, then write down plus AB. Now multiply here, plus AC into C plus AC, plus into minus, minus BC, plus into plus, plus, this is your ABC. So we have got the value for within bracket A star B star C. Okay. So now let us find out. Now let us find out A star Therefore, A star within bracket B star C, right? So which is equal to A star is kept as it is. Now instead of B star C, you have to write this A star B is A star B को definition हामीले यहाँ B star C मा लगाउँछौं. What is the definition of A star B? It is A minus B plus AB. Now instead of A there is B, and instead of B there is C, right? So instead of A, here it is B, instead of B, here it is C. So A को जग्गामा B लाउनु पर्यो, B को जग्गामा C लाउनु पर्यो. So what do we get within bracket here? A को जग्गामा B minus B को जग्गामा C. B minus C plus BC. So it is instead of A write B, and instead of B write C. So this is B minus C plus BC. Now again, instead of A there is A, but what is there instead of B? There is B minus C plus BC, right? So let us use this definition now. यहाँ A भनेको A नै छ, A minus B भनेको थियो यो सबै expression B हो. So write it within bracket B minus C plus BC, right? Then plus AB is there. A भनेको कति छ? A, अनि B भनेको यो सबै expression हो, ठीक हो? So write down B minus C plus BC. So let us simplify it again. So which is equal to A minus, this is your B minus into minus, plus C minus into plus, minus BC. So let us multiply by A here, plus AB minus AC plus ABC. So we have got this expression. That means we got the value for A star within bracket B star C. So this is the expression. So can you say that these two expressions are equal? Are they equal? Let us check it. A, they are equal. Minus B are also equal. But minus C not equal to plus C. Here also AB plus AC minus AC, they are not equal. Minus BC equal, plus ABC equal. So in this case, this minus C and plus C, they are not equal, and plus AC and minus AC are also not equal. That means these two expressions are not equal. Is that clear? So here you can write these are not equal, that is so therefore within bracket A star B star C not equal to A star within bracket B star C. They are not equal. The values of these two expressions are not equal in this case. So therefore, what can you write here? Star is not associative. Therefore, star is not associative. So it is proved. So you can copy it. I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 5. Define star on capital N. Capital N means set of natural numbers. Your capital N भनेको set of natural number. Now this star is defined by M star N is equal to LCM of M comma N. M star N is defined as LCM of M comma N, right? So you have to show that star is a binary operation first. You have to show that star is a binary operation which is both commutative and associative. You first prove that star is a binary operation and then prove that star is commutative as well as associative. Okay? So here given is, so M star N is defined as LCM of M comma N. Okay? So now you have to prove that this star is a binary operation. That is, if M belongs to the set of natural numbers and N belongs to the set of natural numbers, this LCM of M comma N also belongs to the set of natural numbers, isn't it? Suppose, let us take an example, 2 and 3. 2 and 3. Okay, so what is the LCM of 2 and 3? LCM of 2 and 3 is, you know that this is 6. So this 2 belongs to the set of natural numbers and 3 belongs to the set of natural numbers. This 2 belongs to the set of natural numbers. 3 belongs to the set of natural numbers. That is LCM of 2 and 3 is 6. 6 also belongs to the set of natural numbers. So that means star is a binary operation in this case. Okay. So therefore m belongs to the set of natural numbers and n belongs to the set of natural numbers. Therefore LCM of m comma n also belongs to the set of natural numbers. Okay, so therefore star is a binary operation. Therefore star is a binary operation. Therefore star is a binary operation. I think you have understood it. So star is a binary operation, so it is proved. Okay, now what is to be proved here? Star is commutative. So what is to be proved in this case? Star is commutative means m star n is equal to n star m. M star n is equal to n star m. Okay, so now this m star n is defined as LCM of m comma n, right? So what is n star m now? So instead of m we have written n, and instead of n we have written m. So this is LCM of, this is n comma m. So LCM of this is n comma m. Okay, we can prove it. So 2 ra 3 ko LCM kati bha? What is the LCM of 2 and 3? 2 3s are 6. What is the LCM of 3 and 2? It should be 6 again. So 3 comma 2. What is the LCM of 3 comma 2? This is also 3 comma 2 is equal to 6. So they are equal, isn't it? So LCM of m comma n will be equal to LCM of n comma m. So we know that therefore LCM of m comma n is equal to LCM of n comma m, right? That is LCM of m comma n will be equal to LCM of n comma n, that is, which implies that m star n is equal to n star m. Is that clear? That means therefore star is commutative. So star is commutative. Therefore star is commutative. So we have proved that this operation star is commutative. Okay, so now let us prove for associative. So let us take 3 numbers, that is m comma n comma p. So let us take m comma n comma p, which belongs to the set of natural numbers, right? So let us find out first m star n star p. Let us find out first within bracket m star n bracket close star p. Okay, so which is equal to, what is m star n here? What is m star n here? M star n is LCM. This is LCM of m comma n star p, right? So LCM m comma n, that is m star n is defined as LCM within bracket m comma n. So we can write here LCM within bracket m comma n star p. So again here in this case, instead of m there is LCM m comma n, and instead of n there is p. So which is also defined as LCM, which is also defined as, which is equal to LCM within bracket. What is m in this case? Whole thing, that is LCM m comma n comma, here n is p. Is that clear? So here in this case LCM within bracket m comma n, so you will get LCM of m and n. LCM of m comma n means you will get LCM of m and n. And what is LCM of m and n comma p? That is LCM of l comma m comma n comma p. Is that clear? So let us write here now. Which is equal to, this means LCM of m comma n bhaneko ke bhayo? You will get the LCM of m and n, and then again you will get the LCM of m, n and p. That is, you can write here LCM of within bracket m comma n comma p. So let us take an example. Okay, हामी एउटा example लियौं. The LCM of m comma n comma p, यो बाहिरबाट के छ LCM भनेको नै के हो? LCM of m and p. किनभने हामीले LCM of m र n पहिल्यै निकालिसकेको हुन्छ. The LCM of m comma n, that is LCM of m comma n, will give you LCM of m and n, isn't it? That is LCM of LCM m comma n comma p means LCM of m comma n comma p. Is that clear? So let us take an example. You know that 2 comma 3 comma 6 belongs to the set of natural numbers, right? That is 2 comma 3 comma 6 belongs to the set of natural numbers. Don't copy it from here. Okay, you have to copy up to this only. So don't copy from this now, because I'm just giving you an example. Okay, I'm just giving you an example. Okay, so now in this case, therefore 2 star 3 star 6, that is m is equal to 2, n is equal to 3 and p is equal to 6. So this is your 2 star 3 star 6, which is equal to LCM. This is defined as LCM of 2 comma 3 star 6. Okay, so which is equal to, what is LCM of 2 and 3? That is 6. That is LCM is, so let us write here now, which is equal to, again LCM 2 comma 3, don't write 6 here. Let us use this definition. So LCM 2 comma 3 star 6 means LCM of within bracket LCM of 2 comma 3 comma, what is n here now? It is 6. Is that clear? So which is equal to LCM of, what is LCM of 2 and 3? This is 6. What is LCM of 6 and 6? That is your 6. That is, which is equal to, this is your LCM of what? 2 comma 3 comma 6. That is LCM of 2 comma 3 comma 6. That means from this case directly you can write down LCM of 2 comma 3 comma 6. So I think you have understood it. Okay, so यो जुन चाहिँ छ LCM within bracket LCM 2 comma 3 comma 6, from here directly you can write LCM of 2 comma 3 comma 6. Similarly here also we have written LCM within bracket LCM of m comma n comma p. Directly you can write down that one. Okay, so this is just an example. I think you have understood it. Okay, so now this is the value for what? M star n star p. So now let us find out. M star within bracket n star p. Okay, so which is equal to, now this is defined as m star within bracket n star p. So now this n star p is defined as what? Instead of m you write n, instead of n you write p. So which is equal to LCM of within bracket, this m remains same, m comma, sorry, we are writing for this n star p, not for this m star. Okay, so which is equal to m star, what is n star p now? Instead of m there is n and instead of n there is p. Okay, पहिला चाहिँ हामी के को डेफिनेसन लेख्छौं, n star p को डेफिनेसन हामी लेखिहाल्छौं. ठीक छ? So instead of m there is n, instead of n there is p. So it is LCM of within bracket m comma n. So instead of m there is n comma instead of n there is p. So n comma p. So now again this is in the form m star n, isn't it? So instead of m there is m, and instead of n there is LCM within bracket n comma p. So which is defined as, which is equal to LCM within bracket, m is here, m is m comma, what is n here? This is LCM within bracket n comma p. त पहिला हामी LCM of n comma p निकालिरहेको हुन्छौं. So it is equivalent to, which is equal to LCM of within bracket m comma n comma p. So I think you have understood it. So both these are what? Equal, isn't it? That is, we have here m star n within bracket star p is equal to m star within bracket n star p. So therefore we can write here within bracket m star n star p is equal to m star within bracket n star p. That means, what can we say about this operation star? The operation star is associative. So you can write hence star is associative. Hence star is associative. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 6. So that the set A is equal to, set A is given as 3 elements here. Only 3 elements are there. That is -1, 0, 1 is not closed for addition. It is not closed for addition. That means in this case you have to prove that this plus operation is not a binary operation for the set A. So that the set A is equal to, set A मा हामीलाई तीनटै नम्बर मात्र दिएको छ, integers, that is -1, 0 र 1 मात्रै छ, is not closed for addition. So what is the meaning of this question? You have to show that for this addition operation, that is for plus operation, this plus is not a binary operation for the set A. So यो binary भनेपछि हामीले दुईटा एलिमेन्ट लिनुपर्छ. Operation is done on 2 elements. Okay? You know that the relation on a set A, relation on the set A is a subset of A cross A. You know A cross A, isn't it? A cross A भनेको हामीलाई याद छ. So just try to understand it now. A is equal to -1, 0, 1. Right? So now again A is equal to -1, 0, 1. So what is the meaning of A cross A? A cross A भनेको सबैलाई याद छदैछ हैन? So A cross A भनेपछि के कति भयो? That is -1, -1. This is -1, -1. This is -1, 0, and this is -1, 1. Right? Again you can write 0, -1, 0, -1, 0, 0. Is that clear? Then comes 0, 1, right? 0, -1, 0, 0, 0, 1. Again, what will you write? 1, -1, 1, 0, and 1, 1. So this is your A cross A. त हामीले order पे लिँदैछौँ हैन? So binary operation भनेपछि plus addition हामी लिनु पर्यो, दुईटा नम्बरमा लिन्छौँ. अब जस्तै अब जुन चाहिँ यो 1 र 1 छ नि, 1 plus 0 is 1, 1 is here, 1 minus 1 is 0, 0 is also here, 0 plus 1 is 1 here, 0 plus 0 is 0 here only, 0 minus 1 is here, minus 1 plus 1 is 0 here, minus 1 plus 0 is minus 1 is here. But what is minus 1 minus 1? That is your minus 2. Does this minus 2 belong to the set A? No. 1 plus 1 belong to the set. 1 plus 1 is 2 here. So 1 plus 1 is 2, but 2 does not belong to the set A. So this is not closed for addition. That is addition is not a binary operation on the set A in this case. I think you have understood it. So you can draw this figure like this also. You can draw the figure here that is known as the composition table. So हामी यहाँ एउटा composition table पनि बनाउन सक्छौं. यहाँ set A भने कति छ -1 0 1 र composition table हामी कसरी बनाउँछौं भन्दा फेरि यस्तो पाराले यस्तो बनाउने. त यहाँ चाहिँ हामी addition, here binary operation is plus. Okay, set A यहाँ के दिएको छ -1 0 1 अनि यहाँ के दिएको छ हाम्रो -1, यही रिपिट गर्नु -1 0 1 -1 0 1. अब यो एड गर्छौं हामी -1 -1 plus -1 is -2, -1 plus 0, what is -1 plus 0? -1, -1 plus 1, that is your 0, right? 0 minus 1 is -1, 0 plus 0 is 0, 0 plus 1 is 1. Okay, so 1 minus 1 is 0, 1 plus 0 is 1, 1 plus 1 is 2. This is also known as composition table भनेर पनि भन्छौं. So is it closed for this addition? So यो set A मा यो 2 र -2 त परेन नि त यहाँ. So in this case 2 does not belong to A and this -2 does not belong to A. That is 1 belong to the set A, also 1 belong to the set A, but 1 plus 1 is 2, 2 does not belong to the set A. That is, this set A is not closed for addition, or you can write down that the binary operation plus is not a binary operation in this case. Is that clear? So here now we can write 1 belongs to the set A and 1 also belongs to the set A. Right? 1 belongs to the set A and 1 belongs to the set A. Therefore 1 plus 1 is equal to 2. It does not belong to the set A. So 2 does not belong to the set A. So this plus operation is not a binary operation, or you can write down that therefore the set A is not closed for addition, is not closed for addition, is not closed for addition. Okay, so sometimes you may be asked to write down the composition table for this addition for the set A also, that is -1 0 1. Okay, so A लाई भन्छ हामी composition table भनेर भन्छौं. यो composition table, that is composition table. So this table is known as what? Composition table. So I think you have understood it. So you can copy it. So this set A is not closed for addition. Okay, so you can copy it. So now we'll do the next question, that is question number 7. So this question is very important. You can mark it. So this is very important. So this type of question you may get in higher secondary question papers. Okay, so question number 7 is on the set Q plus. What is Q plus? It is the set of all positive rational numbers, of all positive rational numbers. Define an operation star on Q plus, that is all positive real numbers, by A star B is equal to AB divided by 2. For all AB belongs to the set Q plus, A belongs to the Q plus, B also belongs to Q plus. You have to show that number 1 star is a binary operation on Q plus, and number 2 star is commutative, number 3 star is associative, and now in this case you have to find out the identity element of Q plus for star operation, and then you have to find out the inverse of A. What is the inverse of small a? That belongs to Q plus. So I think you have understood the question. So let us prove that star is a binary operation on Q plus. So this is the solution number 1. Okay. So here the definition is A star B is equal to AB by 2. That is A star B is equal to AB by 2. Now you know that A belongs to Q plus. Therefore A belongs to the set of positive rational numbers, and B also belongs to the set of positive rational numbers. So therefore A star B was defined as AB by 2. If A belongs to the set of rational numbers, B belongs to the set of rational numbers, then obviously AB by 2 also belongs to the set of rational numbers. That means this star is a binary operation, isn't it? A belongs to the set of positive rational numbers, B also belongs to the set of positive rational numbers. So obviously this AB by 2 also belongs to the set of positive rational numbers. Okay, so here you can write, therefore star is a binary operation, on Q plus. Hence star is a binary operation on Q plus. Is that understood? So now number 2. Now number 2, you have to prove that star is commutative. So what is the meaning of commutative? You have to prove that A star B is equal to B star A. Okay. So now A star B is defined as what? AB by 2. Now let us find out B star A. So therefore now B star A. What is B star A now? Instead of A, you put B. Instead of B, we put A. So what is there on the right hand side? It will be BA by 2. And you know that this AB by 2 is equal to BA by 2. AB by 2 and BA by 2 obviously they are equal. So therefore AB by 2 will be equal to BA by 2, which implies that A star B is equal to B star A. Is that clear? So hence star is commutative. Hence this star is commutative. Hence this star is commutative. So I think you have understood it. So this is your second part. Okay. Now what is the third part here? You have to prove that, you have to show that star is associative. So what is the meaning of associative? You have to prove within bracket A star B, bracket close, star C is equal to A star within bracket B star C, right? So let us find out first within bracket A star B star C, which is equal to, now let us put the value for A star B first. What is A star B now? AB by 2. Here you can put AB by 2 star C. Okay, so which is equal to, now here A star B is what? AB by 2. So we put AB by 2 for A star B. Again star C is there. Okay, now let us take this A as AB by 2. अब हामी A के लिन्छौं? AB by 2 and B के लिन्छौं? C. So it is defined as AB by 2 again. So A भनेको हामी अब के लिन्छौं अरे? AB by 2. So this is your AB by 2. So let us write here, okay? So which is equal to, now instead of A there is AB by 2, instead of B there is C. It is defined as AB by 2, right? So हामी यो A को जग्गामा अब हामी के लेख्छौं? AB by 2. This is your AB by 2, right? Instead of A, what will you write? AB by 2. Now instead of B, what is there? C. C whole divided by, what is here? There is 2. So which is equal to, if you simplify it, you will get ABC. ABC divided by this, both these 2 are in the denominator. You can multiply them. 2 2s are, that is your 4. So we have got the value for within bracket A star B bracket close star C. Now let us find out A star within bracket B star C. Okay, so which is equal to A star is kept as it is. Now B star C, what is B star C now? Instead of A there is B, instead of B there is C. Since A star B is equal to AB by 2, so instead of A you have to write B, instead of B you have to write C. So this is BC by 2, isn't it? The A ko jagama B ayo, B ko jagama C ayo. So it is BC by 2. So it is BC by 2. Is that clear now? So in the next step, so what will you write in the next step now? So in the next step, instead of A there is A only, instead of B there is BC upon 2. So it is AB by 2 again. So which is equal to, यहाँ A भनेको A नै रहेछ हैन, अनि within bracket यो B भनेको यहाँ कति रहेछ BC by 2. So it is BC by 2. This whole divided by, there is 2 is constant, whole divided by 2. So if you simplify it, what do we get? This is your ABC whole divided by, this is 2 to the 4. This is 2 to the 4. So I think you have understood it. So are they equal? This ABC by 4 is equal to ABC by 4. That means this is associative. So we have proved that within bracket A star B star C is equal to A star within bracket B star C. So this is associative. So hence star is associative. Hence star is associative. ASSOCIATIVE. Hence star is associative. So we have proved the third part. Okay, so now we will do the last two parts. That is, you have to find out the identity element in Q plus for star, and the last one is what is the inverse of A that belongs to Q plus. Okay, so you can copy it. So I think you have understood it, both commutative and associative. Okay, so now we will find out the identity element and the inverse of an element now. So now for identity element. Now for identity element. Now for identity element. So how can you define the identity element? How can you find out the identity element? Okay, so in the last online class we did this identity of an element, isn't it? So how can you find out the identity element of an element that given to the given set? Okay, let S be a given set. Let S be a non-empty given set. Okay, and A belongs to that set S. Suppose an element small a belongs to the set S. So you know that E is the identity element. That E belongs to the set S is said to be identity element if A star E is equal to E star A is equal to A. I think you have understood it. So this is the definition of identity element. I hope you revised all the theory portions that we did in the last online class in binary operation. So in that online class in binary operation, we did what is identity element, what is the inverse of an element. So I think you have understood all that theory portion in the last online class. Okay, so now for identity element, let E be the identity element. Let E be the identity element such that, that is, this is such that such that E belongs to this Q plus. Okay, so if E is the identity element, we can write A star E is equal to E star A is equal to A. So this is the definition of identity element. Okay, so or this A star E is now defined as यहाँ A भनेको A नै छ अनि B भनेको के छ यहाँ E छ. So if A star B is equal to AB by 2, so what will write for A star E? A को जग्गामा यहाँ A छ, B को जग्गामा E छ. It is defined as AB by 2. So this is defined as AE by 2 is equal to, now what is E in this case? A is equal to E and B is equal to A. So it is AB by 2. Here A means E and B means A. So it is EA by 2, isn't it? So EA by 2 is equal to A. I think you have understood it. Okay. So now in order to get the identity element E, either you can equate this AE by 2 is equal to A or EA by 2 is equal to A. You will get the same value for E, right? So now you can equate first is equal to last. AE by 2 is equal to A. Is that clear? So from both the sides you can cancel this A, because A is not equal to 0, because Q is the set of positive rational numbers out here. Q is positive, so 0 is not a positive rational number, isn't it? So you can cancel this A. So here A not equal to 0. Here A not equal to 0. That means E by 2 is equal to 1, or what is E is equal to 2. So we have got E is equal to 2. That is identity element. Therefore identity element for operation star is equal to what? This is 2. I think you have understood it. So we have got the identity element for the operation star, which is equal to 2. So this is the answer. So I think you have understood it. This is very, very important problem. Okay, try to understand it. सायद तिमीले यो बुझ्यौ होला, घरमा पनि यसलाई रिपिट गर्नु, ठीक छ? So next, what is the inverse of A that belongs to Q plus? That is set of positive rational numbers. Okay, so let us assume the inverse of element A को definition चाहिँ के थियो भन्दाखेरि, suppose B is the inverse of A. Okay, suppose B is the inverse of A and we have to write A star B is equal to B star A is equal to E. Then B is said to be the inverse of A. Is that clear? A star B चाहिँ के हुनु पर्यो? E हुनु पर्यो. So let us assume first, let B be the inverse of A. Here also B should belong to the set of rational numbers. So from the definition of inverse of an element, we can write down that A star B is equal to B star A is equal to E. That is, your E is the identity element in this case. Okay. So now what is A star B? AB by 2. It is AB by 2. What is similarly B star A? It is BA by 2, which is equal to E. Is that clear? But in this case, what is E? E भनेको identity element. हामीले के निकाल्यौ? Identity element भनेको थियो 2. So instead of E, you can write 2. Okay. So next, let us get the value for B now. So either you can equate first is equal to last or second is equal to last. So जुन चाहिँ equate गर्दा पनि हुन्छ, first is equal to last or this second is equal to last. So therefore AB by 2 is equal to 2, or now this is B is equal to 4 upon A. You can cross multiply it. A is taken to the right hand side, it goes to the denominator. So B is equal to 4 by A. So therefore inverse of A, that is B. B was the inverse of A, isn't it? So inverse of A is equal to 4 upon A. That is, you can write A inverse is equal to 4 upon A. So this is the answer. which also belongs to this 4 by a also belongs to the set of positive rational numbers. So what is the inverse of a, which is equal to 4 upon a? That is a inverse is equal to 4 upon a. That is the answer for the last part. So what is the inverse of the element a? It is a inverse is equal to 4 upon a. So I think you have understood it. This much is for today. त आज हामीले जति पनि प्रब्लम्सहरु गर्यौं सबै इम्पोर्टेन्ट प्रब्लम्सहरु हुन्। त यो सबै तिमीले घरमा राम्रोसँग रिभिजन गर्नु, ठीक छ? अन्त नेक्स्ट अनलाइन क्लासमा म यस्तो टाइपको प्रब्लम्सहरु अझै देखाउने छु अनि हायर सेकेन्डरी क्वेशन पेपर्सबाट पनि हामीले गर्नुपर्ने छ, ठीक छ? सो दिस मच इज फर टुडे. सो यु रिभाइज all the problems that we did today. Okay?